Hello everyone, welcome back to Business Analytics. Today we are diving into week 9 and we are going to interpret classification metrics. Imagine this, your telecom company is losing customers left and right, that's churn, and it's costing millions. You build a machine learning model to predict who's about to bail, but boasts 92% accuracy. Sounds great, right? Wrong, it might just be ignoring the churners entirely. So in this video, we will unpack scikit-learn's classification report, precision, recall, and F1 score using a real-world customer churn example. We'll see why accuracy is a trap in imbalanced data, break down the confusion matrix, and even tweak thresholds for better business decisions. By the end, you'll know how to turn these metrics into actionable insights. So let's get started. Here's our import in the data set, in the classification report, confusion metrics, all those wonderful things are inside sklearn metrics. And let's make the churn data set. As you can see in business analytics, especially with classification problems like customer churn, data is often imbalanced. And in our example, only 15% of the customers, they actually churn. That's the minority class, and we care about most because retaining them saves big bucks. Accuracy is simply correct predictions divided by total predictions. But if your model predicts no churn for everyone, it gets 85% accuracy without spotting a single lever. That's like a smoke detector that never goes off. Usually, mm, it's useless, right? It's useless. When there is a fire, it just never goes on. Instead, we need a precision, we need a recall, and we need an F1 score. And this comes from the confusion matrix. So the confusion matrix is like a scorecard of your model's hits and misses. Let's train the model first. This is our split in the data set. We stratify by our target and build the logistic regression given the balanced class weights, predict probabilities, and build the confusion matrix. So this is the most important thing, confusion matrix. And let's visualize it. So in our synthetic data set that mimics customer churn, we have 14, um, we have a huge number of customers. You can see the overall number of customers is over 3,000. And we have almost 15% churn rate. We split the data, built the logistic regression model, and accuracy should be around 85%. In the very, very easy regression, which doesn't do anything, which doesn't train at all, 85%, at least 85% is what we expect here to get. First, let's interpret what we see. We see the true negative, true positive, false negative. Let's start with true positive. True positive, these are correctly predicted churn. So, hey, this customer is leaving, let's offer a discount. True negative, true negative, correctly predicted stay. So, no action needed here. False positive, FP, wrongly predicted churn. You waste resources on a loyal customer. So 523 customer, 15% of the data set. And false negative, it's a missed churn. They leave, 83 people leave, and you lose revenue. In terms of the business angle, false positives cost you marketing dollars. False negatives cost you customers, and we want to balance them based on what's more expensive for the business. And let's decide on the confusion matrix. So this is our confusion matrix. This is the confusion matrix, which is beautifully placed. Let's proceed further with the classification report. In the accuracy, it's around it's around 83%. But wait a second. Didn't I just say that a completely dumb model that predicts stay for everyone get roughly 85% accuracy? But so our smart, let's say, machine learning model, our logistic regression that we have trained, is less accurate overall than doing nothing at all. Is it okay or not? Here's the plot twist, and why this is actually a very good thing. Because we used the class uh, weight balanced, the model deliberately sacrifices a bit of overall accuracy to get much better at finding the rare churners, the ones we actually care about. And let's look at the confusion matrix to see why. Uh, we Because of the balanced weights, the model tried really hard to find those churners. We only have 83% the ones missed. They left and we didn't see it coming. It minimized the false negatives, only 83%, but at the cost of raising the false positives. So we can see that the high alarm fired or triggered 523 times. Now let's see what we can grab out of the classification report. We can see that the recall is 83.8, roughly 84%. This matches our strategy. We captured 84% of all the people who wanted to leave. High recall means fear of missing out on a churn. High recall, fear of missing out. Precision, precision is roughly 45%. And this is the trade-off. When our model shouts churn, it's only right about 45% of the time. The other 55% were the false alarms. So, is this a good model? It depends entirely on your business costs. If sending a retention email costs pennies, you don't mind low precision. You'd rather cast a wide net, high recall to catch every possible churn. And if your retention offer is an expensive free iPhone, you can't afford to give it to 523 happy customers, you would need higher precision. So this brings us to the final piece of the puzzle, the threshold tuning. So we can see our precision recall curve for the 0.5% threshold. This is the threshold of 0.5%, 50%, 0.5. And if we move our threshold throughout from 0 to 1, how much change in the precision and recall we can see. So this brings us to the threshold tuning. Default model splits yes and no at a probability of 0.5. But look at the threshold versus matrix chart that we have generated. If we lower the threshold to 0.3, we catch almost everyone, right? Recall, recall is very, very high. But we spam more loyal customers because precision over here, precision is going down. Um, if we raise, let's say, the threshold to 0.7, we only flag the sure things. Precision go up, but we'll let more churners to slip away unnoticed because the recall goes down. And we always see this kind of balance. If we raise precision, recall goes down. If we lower precision, recall goes up. So the bottom line is never stop at model.fit. Always look at the confusion matrix for the minority class. Pick a probability threshold that makes sense for your specific marketing budget. That is the difference between a data scientist and business analyst. Thank you for watching.